So here you have the first one. A student carries out a series of determinations of the acceleration of free fall. The table shows the result. Then you're provided with the values. Okay, what can be said about this experiment? So you have to pick from accuracy and the precision. If we take a look at the readings, and from the even from the data sheet, you get to know the value of G, which is 9.81 meter per second square. So the readings that you have here in the table, they are not close to the true value. So this is not accurate. But if you check the readings are very close to one another. So these are precise but not accurate. It is not accurate but precise. Okay, let's move on to the next one. Which experiment technique reduces the systematic error of the quantity being investigated? Okay, so the first one reads, adjusting an ammeter to remove its zero error before measuring a current. So zero error is a systematic error, and if you get rid of the systematic error, if you get rid of the zero error, you fix for the zero error, so it means that you'll be getting rid of the, or at least reducing the systematic error. So A would be the right one for this question. A student makes measurements for which he calculates the speed of sound as 327.66 meter per second. She estimates that her result is accurate to plus minus 3%, to 3% basically. Which of the following gives her result expressed to appropriate number of significant figures? Okay, for this one, you see the given value is 327.66. What you can do is you can find 3% of it. So 3 divided by 100 or times 0.03. Then you hit it on the calculator. So what we get is 327.66 times, we get 9.8, and in one significant figure it would be 10, because this percentage was also in one significant figure. So if you write the uncertainty, so this is the uncertainty that you'll be having, so 327.66. so you write the uncertainty over here, so that means you'll be rounding off to the 10th place. So after this place, or at this place, you have to start rounding off, because the uncertainty is at the 10th place, not at the unit place, but at the 10th. It starts from the 10th place. Had it been, let's say, if the uncertainty were 5, so it means the uncertainty is at the unit place. It commences from the unit place, and we would have been rounding off at the unit place. But that's not the case for this one, at least. So we have to round it off to the 10th place. So it would be rounded off to 330. So from the given options, it is 330. Okay, let's take a look at the next one. A quantity X is measured many times, and then plot is given. Which graph could be obtained if the measurement X has a large systematic error but a small random error? So if the systematic error is there, it means the readings, the average of the readings would not be close to the true value. So this one has no pretty much no systematic error, because the peak is passing through the true value. X0 is the true value. It's written over here. So if the peak is passing through the X0, it means that there is no systematic error. Systematic error is almost none. So can't be B as well, because the peak is passing through the true value. Can't be D. There is systematic error. Peak is not passing through the true value, but the problem is this one has a high random error as well, because there's large scattering of the data. The width of the graph is quite large. It means the values are quite different from one another. So those are not precise. But for option C, the values are close enough, but they are not close to the true value. So C is the answer for this one. Let's take a look at the question number 5. A steel rule can be read to the nearest millimeter. Okay, then the lengths are given. Are the readings accurate and precise to 1 millimeter? Okay, you see the difference between any of the two readings is not more than 1 millimeter between any of the two readings. So the range is 1 millimeter. So yes, it is precise to 1 millimeter. But what is the true value? It is 895. Are the readings close enough with respect to 1 millimeter range? No. Within 1 millimeter range, the readings are not close enough. So what do we say? They are not accurate, but they are precise. So for 5, we have B as the right answer. Okay, let's take a look at question number 6. What is the uncertainty in P? So P is the power, is given over here. The expression is also given. So even if you have not studied the topic of electricity, I mean even at IGCSE or O level, you study this formula of power, but even understanding of this formula is not required here, at least for this question. You need to find the uncertainty in P. How many quantities do you have in the formula? V square and R, and they are being divided. What do? You add the percentage uncertainties. So what is the percentage uncertainty of V? Potential difference 3, but we'll be taking 6% because you have V square. If you were having the cube of V, then you would have been multiplying the uncertainty of V by 3. Okay, according to the rules. So for the resistance, we have 2. Now we add these two. What do we get? We get 8%. So the percentage uncertainty of P equals twice the percentage uncertainty of V plus the percentage uncertainty of R. Okay, thermometer has the uncertainty. You can call it delta T. This is the absolute uncertainty in the temperature. This is your T1 and this is your T2. And what do you need to find? You need to find the percentage uncertainty in the measurement of the temperature rise. Okay, so you need to find the principal value first as well. For what? For the temperature rise, for the difference in the temperature. So the difference in the temperature would be T2 minus T1, which would be 60 degrees Celsius. But with the uncertainty of, okay, this question is kind of a deceptive one. So what is the absolute uncertainty in this case? Keep it in mind, whenever you add or subtract the values, whenever you add or subtract the quantities, the absolute uncertainties are added. So you get the final answer as 60 plus minus 0.5 plus 0.51 degrees Celsius. This is your principal value, and this is the total absolute uncertainty in the principal value. How do you get 1.0, 0.5 for the first reading, 0.5 for the second reading? Achha, what do we do afterwards is we can find the percentage uncertainty now. So absolute uncertainty divided by principal value times 100. So 1.0 divided by principal value multiplied by 100. So what do you get? We get 1.7 as the answer. Let's take a look at the next one. In a simple electric circuit, the current in the resistor is measured. So this is the current, this is the principal value, and this is the uncertainty. And the resistance is given. This is the principal value, and this is the uncertainty. Which one? The percentage uncertainty. Okay, what would be the percentage uncertainty in the value obtained for the value of power? Okay, so for power, first you need to be able to come up with the formula. P equals to I square R. If you're provided with the current and you're provided with the resistance, then you should be able to, recall the formula of electrical power, I square R. So whenever the quantities are being added or multiplied or divided, what do? You add the percentage uncertainties. So the percentage uncertainty of R is already given, which is 2%. But the percentage uncertainty of current is not given. Current की जो आपको absolute uncertainty given है. So we can find the percentage uncertainty first from there. So 0.05 divided by principal value 2.50 times 100. Now let's try it on the calculator. 0.05 divided by 2.50 times 100. We get 2. So the percentage uncertainty in current is 2%, but we have the square of the current in the formula. So what do you get? You get 2 times of 2. 2 times of 2%. So what is the final answer? 2 times of 2%, 4. 4 plus 2, 6. So C is the right answer for this one. Okay, let's take a look at the next one. You're given with the value of time, you're given with the value of distance, you need to find the average speed and the uncertainty. Okay, so what we have is, for speed, let us find the principal value first. Speed equals to distance over time, 40.0 divided by 2.50. So you hit it on the calculator, 40 divided by 2.5, you get 16. So 16 would be your principal value. And if you want to write in the consistent number of significant figures, so it would be written as 16.0. So you keep 3 significant figures in the answer as well. But we need to find the we need to find the uncertainty as well. So in the formula of speed, you have distance and time, and these two quantities are being divided. Whenever the quantities are being divided or multiplied, what do? You add the percentage uncertainties. So what is the percentage uncertainty of first one? For time, it would be 0.05 divided by 2.50 multiplied by 100. What is the percentage uncertainty of distance? 0.1 divided by 40.0 multiplied by 100. So if I find for time, it would be 0.05 divided by 2.50 multiplied by 100. We get 2% for this one. And for the next one, 0.1 divided by 40 multiplied by 100, we get 0.25, 0.25%. Okay, and after that, we add these two percentage uncertainties, so we'll be getting 2.25%. So 16.0 plus minus 2.25%. But in the answers, they have asked for the absolute uncertainties. In all the options, they have given the absolute uncertainties. So what we can do is we can find how much, or we can find what is 2.25% of 16. So we write 16.0 times 2.25 divided by 100. We get 0.36, and the uncertainty was given in 1 SF over here and over here as well. So in 1 SF it would be 0.4 meter per second, and this would be C would be the right answer for this one, for question number 9. Okay, let's take a look at this one. Yeah, it's just the same. These readings are not accurate, but they are precise within the given range of 1 millimeter. So not accurate but precise. Okay, then we have question number 11. The density is calculated to be 2.5 gram per cubic centimeter. What is the uncertainty in this result for the density? Okay, so let's check it out. So for the uncertainty in the density, first of all, let us write down the formula. Density equals to mass over volume. Or let me write on this side. Density equals mass over volume. In the formula, we have two quantities which are being divided. We need to add their percentage uncertainties. So for the mass, what do we have? Mass as it is, but the volume is not given directly. So we write length times breadth times height. Let us now find the percentage uncertainties of all of them. Delta m%, and we find the percentage uncertainties of all three of them as well, because we have four quantities in the formula: 1, 2, 3, 4, and they are being multiplied or divided. So we gotta find the percentage uncertainties of all four of them for this one, and delta H for this one. So for the first one, we'll be having 0.1 divided by 25.0 times 100. For the second one, you have 0.01 divided by 5 times 100. For the third one, you have 0.01 divided by 2 times 100. And for the last one, you have 0.01 divided by 1 times 100. Then you hit it on the calculator, all of them. So for the first one, it would be 10 divided by 25. 0.4%, and the second one would be 1. 0.01 times 100 would be 1. 1 over 5 would be 0.2%, and the third one would be 1 over 2, which is 0.5, and the last one would be 1%. Then you add all of them. 0.4 plus 0.2, 0.6 plus 0.5, 1.1 plus 1. So we get 2.1%. 2.1% of what? 2.1% of the principal value. What is the principal value of density? It's given in the question 2.50, and you can find 2.1% of this like this, and then you can hit it on the calculator. We get 0.05. So for this one, question number 11, we get C is as the right answer.